Welcome back. We're on Chapter 4, Lesson 2. Please turn with me to page 265, Multiplying Fractions and Whole Numbers. So, we want to talk about the vocabulary. So we're going to talk about the commutative property. The commutative property can be performed in any order. It's like getting on the bus. When you get on the bus, you may not get off the bus in the same order. Now I have a guest lecturer. Jennings, take over.
Alright, so first off, let's go ahead and read tying your left shoe and tying your right shoe. This is a big thing because you have to do both. You cannot take one off. So let's go ahead and see which ones are commutative and which one is not commutative. Well, if you look in this paragraph right up here, it says addition and multiplication are commutative. So this means multiplication right here is commutative, and addition is also commutative. But division cannot be commutative because 12 divided by 6, you can do it, but 6 divided by 12, you'll get an answer with negative. So we cannot do that.
Okay, the one thing that I want to just make a comment on is that this doesn't produce a negative answer, but it would produce 1/2, where this would produce 2. So, again, he is correct. That is not the commutative property. The commutative property, the associative property, and the identity property can only be used with addition and multiplication. That is it. You may not use it for division or subtraction. Why? Because you would get a different answer.
Well, let's go ahead and read the real word link. Some morning routines can be done in any order. Sometimes the order matters. I'm going to describe a situation when the order you perform 2 actions is important. Well, I think you have to put on your socks before your shoes, so let's put socks before shoes. Sorry for this bad handwriting, I cannot draw on this thing. I can't see it. And it would always look weird if you put on your socks over your shoes. So this is probably a great example. It's like eating soup with a fork. That would just be weird. We can't do it. Shoes.
Awesome, Jennings. Thank you so much for being my guest. See you soon. Bye. So the big deal that you need to look at when you're multiplying whole numbers by a fraction is taking the whole number and making it into a fraction. Any number n can be made into a fraction by putting it over 1. 1 is the identity property. Alright, so we're going to look at the examples. We are not going to model, we're going to do the math. In the modeling example, wow, we just had power out. Did anybody else see the screen go blank? Now that our screen's back up, let's look at this. Alright, so we're going to look at the problem 2 times 2/5. So 2 over 1 times 2/5. We are always going to multiply across, but prior to that, always look to see if you can simplify. 2 does not go into 5, we cannot simplify that, and 1 goes into 2, but that's the identity property, so there's no point in crossing that out. So now we're going to multiply across. 2 times 2 is 4, 1 times 5 is 5. Now, half of 2 is 1, so in my head, I knew the answer should be somewhere around 1, and 4/5 is close to 1. All right, let's get the problems done.
Pause the video! Yeah.
Did you get 4, 3, and 1/2? Those are the answers to these problems. Now, let's look at C up close. 4 over 1 times 1/8. Again, I always go from the small to the big number when I'm simplifying within the problem. 4 goes into 8 2 times. That means we have a 1 on top, so 1/2. And again, I will always go from the little number to the big number, draw my arrow so that I put the number in the correct spot and get the correct answer. It's very important that you do this. All right, turn the page. Alright, so again, let's talk about the commutative property. If I switched 1/2 times 1/3, I get 1/6. If I go 1/3 times 1/2, look, I still get 1/6. So what we're saying is order is not important. Same thing goes for addition. Now let's look at the problems. Again, in modeling, we are going to move straight down to the actual multiplication of the problem instead of modeling. So 3/5 times 4/1. Can't simplify 4 and 5, can't really do anything with a 1 and 3, so all I can do is multiply across and I get 12/5. I know that 5 goes into 12 2 whole times with a remainder of 2, so I get 2 and 2/5. Now, I can look at this as a half. A half times 4 is 2, so my guess of what I think the answer should look like is somewhere around 2, and I get 2 and 2/5. Makes sense. All right, let's do the problem. All right, in problem number 3, we have finding 1/4 of 5. Well, we know 1/4 of 4 is 1. So again, my guess for this problem is 1. We got 1/4 times 5/1, which is 5/4. We can pull out one whole number, and then we have 1/4 left. So again, 1 is close to 1 1/4. All right, time for you to work. Get it, gotta go.
Pause the
Okay, so we're getting improper fractions here that we need to turn into mixed numbers. For number D, we get 3/2, which is 1 1/2. E is 8/5, which is 1 3/5, and F is 15/4, which is 3 3/4. And again, I put my estimates down just to make sure that my answers are logical. In each case, my answers are close to my estimates. This is good. Turn the page. Okay, life is really about real-world problems. Let's read the problem. A sloth spends 4/5 of its life asleep. If a sloth lives to be 28 years old, how many years did it spend asleep? Now, let's talk about keywords. The word of will always mean to multiply. The word is will always mean equal. So those will help you when you're writing problems. So we know 4/5 times 28, so we again put that over 1. We cannot simplify within the problem, so we know we get 112 over 5. 5 goes into that 22 and 2/5 times. So a sloth will sleep most of its life. Boy, that's boring. All right, so get the guided practice done. See you soon. Okay, so please check your answers. Number 1 is 8, 2 is 1 1/2, 3 is 4 1/8, 4 is 3 6/7, and number 5, a cat will spend 2/3 of its life asleep. If it lives for 15 years, that's 10 years that he'll be asleep. Boy, that's sad. And again, how is the process used to multiply a fraction and whole number similar? You multiply across. It's very simple. All right, see you in class. Bye.